Well, this is sort of a mixed review of solving equations in beginning algebra. With this, when you've got fractions in an equation, what I would suggest is you get the least common denominator. So for the denominator 3 and 9, that would be least common denominator is 9. And then realize that there's three terms, the 1/3 x, the 2/9, and the 1. And you just multiply all of these by the 9. So multiply by a 9, multiply by a 9, and multiply by a 9. Then what that's going to do is that's going to get rid of all the fractions. So 3 divides into 9 3 times. So that means for that one, it's a 3 times 1 times x. That's 3x. Over here, actually, the 9s are going to cancel completely, leaving just a plus 2. And then on the other side, it's just a 9. Then just two more steps. One is subtract 2 from both sides. So if you subtract 2 over here, it's going to be 9 minus 2 is 7. And then divide both sides by 3. So x is going to be 7 over 3, which can't be reduced, so it's done. Over here, to get rid of a square root, use the opposite operation, which is squaring. So just do the same thing to both sides, square both sides. On the left-hand side, it's going to get rid of the radical, leaving only 2x plus 3 equals a 25. So then, just subtract 3 from both sides to get rid of this 3. If you subtract 3, that's going to be a 22. And then, for the last step, divide both sides by 2. X is going to equal 22 divided by 2 is 11. Now the only thing is, when you square both sides, this method sometimes gives you answers that are not correct. It could be that this has no solution at all, yet when you square it and do the algebra, you end up with x equals 11. So this is the one time when you have to check your answer. So if I take the 11 and substitute it in, the square root of 2 times 11 plus 3, does that equal, on the other side was a 5. Does it work? Well, this would be 22. 22 plus 3. 22 plus 3 is 25. So is the square root of 25 equal to 5? Yes, that's true. So now I could circle that one and keep x equals 11. Well, what we did over here is essentially what we're going to do over here. So the opposite of squaring would be square root. But the thing is, when you take the square root of both sides, you have to say there's positive or negative the square root of 9. So we would have 3w plus 1 is equal to positive or negative 3. The reason that you have to do this positive or negative thing is, let's say you have x squared equals 25. So what is x? What number could you square, multiply by itself, and get 25? Well, if you have 5 and you square it, that means 5 times 5, so that's 25. So x equals 5 is an answer. Well, what about if in the parentheses, or in for x, you put a negative 5? So that means negative 5 times negative 5, two negatives will cancel and gives you 25. Oh, so that means that x equals negative 5 is also an answer. Or instead of doing it this way, we could have said, okay, go ahead and take square root of both sides, but just put the plus or minus. And then that would give you this, in this case, automatically. All right, back to this one. So now that we have a plus or minus, it's best to break this up into two cases. You go, the 3w plus 1 equals a positive 3. The 3w plus 1 equals a negative 3. And then just work on these separately. For this one on the left, the next step is to subtract 1 from both sides. If you subtract 1 from this side, it will leave a 2. Finally, divide. So divide both sides by 3, it's going to be the fraction 2/3. Next up, to finish this one, subtract 1 from both sides. So if you subtract 1 from both sides, the right-hand side is going to have negative 4. And then the last step is divide by 3, so the fraction negative 4/3. With this squaring, this one can give you answers that are not correct, so you have to check. With this square root, that doesn't happen. You don't have to worry about that. So you could check these if you want, but I'm pretty sure they're right. When a fraction equals a fraction, we've got the beauty of cross multiplication. So we'll have 2 times 3 is 6. And then this one, x times x plus 2. So on the one hand, we have 6. And you can put that on the right or the left side of the equation. And then multiply x times x and 2. So that would be x times x is x squared. And then x times the positive 2 is 2x. Now that we have a squared term, a not squared term, and a number, then you have to have it set equal to 0. So we need to subtract 6 to move it to the left side. X squared plus 2x minus 6 equals 0. Then, do we factor or just go straight to the quadratic formula? Well, with factoring, we would have to have two things that would multiply to give you 6, like a 2 and a 3, and they have to have a difference of 2. So a 2 and a 3, that only has a difference of 1. If I used a 1 times 6, well, that is a difference of 5. So that's not going to work. So I need to use the quadratic formula. So x is equal to, just as a quick reminder, quadratic formula goes like x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so that's what we're going to use. This is the a is a 1, the b, and the c. So negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So we've got negative 2 plus or minus the square root of what? Well, a negative times a negative is a positive 24, and this is a positive 4, makes a grand total of positive 28. And we need to keep going because a 28 can be factored as 4 times 7, and you could take the square root of the 4. So we would then have x is negative 2 plus or minus, take the square root of 4 is a 2, square root of 7 can't be simplified. But then there's one more step. Because we've got a 2 and a 2 and a 2 showing up in all three terms, we need to reduce. So divide by 2, divide by 2, and divide by 2. So that's going to leave behind negative 1 plus or minus the square root of 7.